Hey guys, welcome back to the shop. So we're jumping right back into our American Pacemaker coolant sump project. We got a couple of blocks we need to machine, and I want to start getting the new plumbing system from the sump pump up to the tool post. Try to get all that installed. So I'm gonna bring you here and show you what we got to make, and we'll go ahead and get started on this, okay? So we've already got our coolant system ready to go. We got no leaks. It's working just fine so far. So I wanted to show you what we're going to be doing here. I've got a couple pieces of aluminum blocks that we're going to machine into a couple of just very simple manifolds. All right, we're using aluminum because these are some blocks that I just had laying around, and they're going to be really easy to machine, and I think this is going to work pretty good. So we've got two that's going to be mounted on here. So the first one's going to be for this location. This is the original spot where American Pacemaker had some kind of block mounted on here for a coolant pipe that went up. I haven't seen one of these before, so I don't know exactly what that looks like, but what we're going to do is take this 1-inch thick aluminum and machine it so that it bolts on right there. And it's also going to be drilled and tapped on the side for an MPT fitting. It's going to be drilled and tapped on the top for MPT fitting. So coolant will come in from the bottom, go up and out. It's be mounted here like this, and then our coolant will come up and over to the tool post. This block here, it's another piece that I had cut off. We're just using this because it's what I got. And we're going to be mounting another little manifold right here. So this is where the original pump used to be. This was some kind of bracket. I don't know exactly what this bracket was made for, but it's extremely heavy duty. I don't know if it was to help support the pump or had to do with the electronics or anything that went on there. But what we're going to do is make another manifold just like the other one that I just showed you. We're going to use these two holes right here. We're going to have this drilled and tapped. It'll bolt right underneath that like so. I'm going to have MPT drilled and tapped on the bottom. And we're going to have an MPT drilled and tapped on that side so that coolant will come up from that pump to this block. That way I don't have some kind of hose that's just hanging over here and pulling this little pump around. So anyway, it's going to mount there, and then we'll come out this side with our hose, and we'll route it probably using this old coolant pipe right here and kind of attach our hose to this guy, and then it'll come up from here to this manifold right there. Okay, not going to look as cool as the original stuff, but it's going to be functional. It's going to work just fine. I would like to try to utilize that original coolant line right there, but I just didn't feel like messing with it, so we're just going to go with a hose down here to that manifold. So that's what we're going to be machining. Get those two blocks. I'll show you my prints here in a second. This is the pump that I got. This is a little giant Model 2E. I got this from KBC Tools. This is one that they had in stock, and it works really good. I've ran other machines that have used the same exact pump. On the dual saw, I think it was a Kalamazoo had it on there, and they've always worked really well. So the plan is that it's going to drop in right here where the original pump used to be mounted. It's going to sit down in that coolant, and then for now we're just going to take it and we'll just plug it into the wall right there whenever we want to operate it. I'd like to eventually have this wired in, maybe put a box back here and have it wired in so that we have a switch over there that we can actually turn the pump on and off whenever we want to. But for now, we're just going to do the old plug and play. I will show you this guy working. I already tested it out once over here in the sink. I'm just going to lay it on the side because it's got quite a bit of pressure to it. You can see it's going to provide quite a bit of flow there for our coolant. So no reason why that won't work for a coolant pump. So that's what we're going to be running right there. All right. So let's go over to the mill. We're going to get our two blocks machined. So this morning I went ahead, this is a diagram that I just kind of drew up, kind of showing the system, how I wanted to mount it, just trying to figure out what kind of piping connections and hoses that I need to get everything hooked together. So I got on Fusion 360 this morning and went ahead and just drew these guys up so I could have a nice looking print there to go off of. Very simple in detail. A couple of holes that we're going to drill and tap to mount it. A couple of holes that would be drilled and tapped for our NPT fittings. The other print is exactly the same way, just shaped a little bit differently. I got our overall dimensions of what I want it to be. And then we have our mounting holes right here. These are just going to be 1/2 inch holes that'll go into these tapped holes right there for 1/2 inch. And then we have a couple of MPT holes that are drilled and tapped in there as well for our MPT fittings. All right, so let's go over to the mill, get these guys milled. I'm not going to go into any kind of great big detail and explanation of the machining process for this. You guys have seen lots of that. We're going to put them in here. We're going to use our face mill them to size. We'll put a drill chuck in there, drill it and tap it as needed, and get these guys done. So let's go ahead and get started on it. We're going to start with our thickest block first. This piece right now is right around 1 inch, 835 thou thick. I've got it designed. We're going to make it just 1.5 inches thick. So we'll mill the top off, and then we'll flip it over and clean up the other side. Using a 3-inch Walther face mill with our aluminum cutting inserts. And we're going to try a 200,000 step to cut on this first pass to see what happens. I think I'm going to go ahead and run our mist on here too. Help give it a little bit of lubricant. See what happens here. Kick up the feed. I think that did pretty good. A little bit of a heavy cut. On the mills, I generally like to feed it from the left to the right here, just so that it slings most of the chips that way. You can see we got some pretty good looking chips. Let's take another 100 thousandths. Go the opposite way this time. This is technically going to be my finished cut on this side. All right, that looks good, feels good. We'll flip it over, clean up the other side to 1.5 inch thickness. Go deburr this and then we'll clamp it back in there. So we got about 45 to bring it down. Keep in mind, all these tolerances or these sizes are very loose. It's just something that I'm making up as I go. We'll just take a couple passes on there. That way I can measure it and get it on 1.5 inches. So we'll just take 25 and then I'll mic it. Just get in here with our mic and get a measurement on this. All right, so it says we got about 18.5 thousandths to bring it down. So we'll go 18 and a half. 10, 15, 16, 17, 18, and 1/2, and then we'll play a little game at the end and see how close I got to it. Finally got some of that beautiful weather here. I know it's blowing out there, but we've been getting, you know, 70s and 80s here in Florida. It's been great. Love having the door open whenever I can, turn the ACs off and enjoy some sunlight in here. All right. That looks good. Let's give it a mic and see if I hit it on my target. About a 1/2 thousandths over. Not bad at all. I think that'll work. Okay. Need to do just a little bit more shaping on it. We've got bandsaw cuts on the side. So we want to finish kind of getting this shaped the way we want to before we move on to our drilling. So on my thicker block here, I designed it to be 3 by 3. You have 2 bandsaw cuts, and then you have this side, the extruded side, so it should be nice and square. I think I'm just going to clean up the bandsaw cuts, but what I'd like to do is just set it in here and just side mill it, because those are probably not going to be square if I set it on there. Just make it simpler, just to set it like that off to the side mill it. So let's go ahead and move on to the 1-inch thick and just go ahead and get our thickness there, which is going to be 2 1/4. We'll go ahead and get that milled, and then we'll swap out our face mill with a collet so we can put an end mill in there and just side mill it. Don't need much here. It'll take about 20 thou and then clean up the other side. Already got the jaws cleaned out. So I'm setting up an end mill to do our side mill in here, and I wanted to give a shout out to these guys over at Martin Precision Tools. They build these adapters here that you use just a standard torque wrench that's made for different types of collet wrenches, or different types of collet chucks, I mean. And they sent me the ER40 as well as the ER32 torque wrench adapter. You can see that one right here. And they've got this QR code on here, so you can just scan this with your phone, and when you do that, it'll actually pull that particular wrench up, and whenever you do that, it's going to ask you the length of your torque wrench. You put that value in there. Mine was 16.5 inches long, and put that in there, and it tells you what the use adjusted torque, in my case it's 106.7 foot-pounds. All right, so We've got that adjusted to it 100. I just put it at 106, and you can just, well, there we go. You can just snap it onto your torque wrench, right? And then you can use your torque wrench here to tighten your collet chuck up, just like that. So I think these are pretty handy to have, because I've never had a proper torque wrench for the ER40 other than just this wrench that it came with, you know. And these are just cut out of a piece of steel. They're uncomfortable in your hand, and they don't give you any kind of torque value other than just, you know, feel. And that's all I've ever done with that ER40 collet chuck. So big thanks to the guys over at Martin Precision Tools for sending these over for me to try. I think they're excellent tools, good quality cut on this. I like the laser marking that they did. So check these guys out. Martin Precision Tools, made in USA. All right, these ends aren't going to take much to clean them up, about 35 to 40 thou. So let's just clean one side up. I think I'll just take like 20 thousandths. Do a quick measurement on this. See what we got. 21 and a half. So I think what we'll do is just go ahead. We'll climb mill this side since I'm over here on that side. No, I'm not going to climb mill. I don't want to take the risk of pulling into it. About like that there. All right, let's see. All right, let's see what we hit on our size. Just something close. 3" 998 and a half. Overshot it a little bit. No big deal. I was looking for 4". All right, that's good to go. Now we'll move into our thicker block and go ahead and side mill that. We got about 50 thousandths to get this guy cleaned up. We'll just take 25 and then clean up the other side. Nine thousandths. I think we'll go ahead and climb cut on that one. Let's see how it handles it. Put just a little bit of drag on the Y-axis here. Not bad. All right, that should have that taken care of now. We'll start with our 2 1/4" tapped holes. All right, 0. And then we want 3/8. All right, 3/8. And we'll find the center of it. Zero out Y. All right, do half of that, half Y, it's gonna be 1.5 inches. All right, that's the middle of it right there. And we have a 2 1/16 center to center on those 2 1/4-inch holes. Spot them, we'll drill them with our number 7 drill, tap size for 1/4-20. I'm just going to go ahead and get a depth established here on my scale up top. Bring it down to the 1-inch line, and then we're going to go 3/4 of an inch. I'm going to go ahead and we're going to use this spiral fluted tap here to power tap it. I'm just going to go in there, I don't know, about halfway, and I'll back out and I'll run it in there by hand from there. Let's go ahead and put a little bit of our anchor lube on here. Let me see where it's at. Go ahead and back it off. Let me get a chuck wrench or a tap wrench. Pretty good right there. And if I need to, I can just run a bottom tap down in there too. I just don't want to bottom it out and spin in the chuck or break the tap off. That looks good. The polished taps, the polished flutes work better in the aluminum than the black oxide, the steam oxide, but I don't have one. I thought I did, but I don't. So I got to use what I got. Doing it that way just assures that it's going nice and straight in the hole, and then you can finish it by hand here. We're tapping aluminum, so it's pretty easy. And I'll just take a bottom tap run in there and make sure we've got threads down as far as we need to go. All right, well, that should take care of those 2 holes. So we got to take it out, stand it up to do a hole here, and then the other one's going to be on the opposite side of these tapped holes there. Just use an edge finder this time since we've already got a chuck in here. All right, so we want 1/2 inch from the edge. X0, so we're gonna go 600 thou. All right, and then we want it in the middle. Let me make sure, yep. So I've got it designed so that it's in the center of the block right there. So we're going in with a 7/16 drill. I'm using my good Cleveland drills here for this job. This one's going to be about 3/4 deep. Let me get me a depth set. So that's on the 2-inch mark right there. So we're going to go about 3/4 deep. All right. We'll go ahead and get our pipe tap and go ahead and tap it. Maybe we'll go ahead and chamfer that first. Usually it ends up cutting the chamfer off, but it's nice having one on there when we start. All right, so we've got our 1/4 inch NPT tap here. Got our anchor lube on it. Just gonna do this by hand. Now I don't have a gauge or anything to measure the depth there, but what I usually do is just take a good fitting. This is the fitting that's gonna go in there, and we'll just tap it so that we know that this screws in there like it should. Spring-loaded center. So I usually go about halfway. It's usually a little bit more than that, maybe up to about 2/3 the length of the threads, but that's why it's good to have just a little gauge there. You can screw it in and make sure you get the depth right. All right, let's see how that fits. Looks like it was just over halfway of the tap. Wouldn't hurt to go just a touch more, but that looks pretty good right there where it's at. It's going to tighten up as we get it, as we put a wrench on it there. So we're going to have a few of these. These are the barb type fittings that screw in, and the hose that I have is designed to just simply push on there. It's got a really, really tight interference fit where you don't have to use a hose clamp or anything on that. It's got a nice sharp barb so that it doesn't pull off there. So we do need to chamfer that one more time. It kind of took all the chamfer off, which it usually does. Just make it look nice and clean there, like that. All right, I think that's gonna work. We can go ahead and move on to our other tapped hole. All right, one more hole to drill and tap there. Just gotta get centered up on it. All right, starting to come through the bottom here. All right. Just over halfway of the tap right there, or right there at it. I think I might go a couple more threads. It's probably good where it's at, but it wouldn't hurt to go just a little more. see. 1, 2. All right. There we go. This would be a good fit on that pipe nipple right there. Okay, well, this block is done. I would like to hit that chamfer one more time, clean it up some. Makes it just look nice and uniform. Machine finish there. Okay, I think we can go do a test fit and see what it looks like. Just like so. And bolt underneath that bracket there. We have coolant coming in, coolant going out. Let's go see if it'll bolt up, match up to those holes that are drilled in that bracket. All right, here's that existing bracket with the holes that were drilled in it. And so I designed it to go just like this, just utilizing what was already here. I've got some stainless steel 1/4 inch bolts. That one's going in. And it looks like the other one's lined up. Looks like it lined up good. I just scaled and measured that hole pattern right there. That's going to work nice. I think that's going to work pretty good. And then here's a 6-inch, I believe that was a 6-inch pipe nipple, 3/16 stainless. We got a coupling right there. And then our pump, it's just going to screw onto that nipple there. So I have to get all this installed, put some Teflon tape on there. And then, so what we'll do is drop this guy. Is it going to go? Yep, there we go. It's going to drop down in there like this. Something like that. And then we'll have we're just going to make up a little short piece of hose that's going to go from here to the bottom. And then that way this is not connected to anything else. Because I originally was thinking, well, I'll just put a hose here and just bring it all the way to the carriage. But then it's going to be doing this. It's going to be pulling the pump around. So this just needs to sit in there and not be messed with. So just a little short hose there, connected right there. And I think that's going to work pretty good. And then this one right here, we'll take our hose and go out this way. And I think what I'll do is I'll just bring it around to that pipe, probably just put a couple zip ties on it to this point. And then from there, we'll have some slack where we'll have movement, but it's going to go from about right there up to this place where our other block is that we're machining. So that's the next one. We got to get back on that, but I'm real happy with the way this is working out there. All right, guys, let's get our carriage manifold finished up. Once we have this one finished, we should be able to start assembling everything. So there's a little better look at what we're going to be machining right there. So we'll go ahead and start with our MPT holes. Got to drill it down 3.5 inches, tap it for MPT, rotate on its side, go in this way, drill and tap for MPT. And then once we get those done, we'll just lay it back down and we have our 2 1/2-inch holes there for the bolts that hold it on. Pretty simple. So let's go ahead and let's get moving on this guy, get her done. Center of the thickness there, and then 3/4 of an inch from this edge over. Sometimes I like to just double check it, but yeah, there we go, 3/4. Spot it. Let me get my depth set here on the scale. That's on 1 inch right there. 1 inch, and then we want to go, how deep? We want to go 3.5 inches deep, all right? This one's also going to be 3/4 from that edge where it intersects. All right, that's looking good. Go ahead and take it out of here. Got our 2 manifold holes. So all we got left now is to drill the 2 1/2-inch holes. Just put them on our step here in our step draws. All right, so our manifold hole is on this side here. 1/2 inch from this edge, 2.5 inches center to center, centered on the block. So we want 2.5, so it'd be 1.25 inches each direction. And it's 250. All right. We'll spot them and then drill them. And actually, I grabbed the wrong drill. It's a 1/2-inch drill. We're going to go ahead and drill them. I believe it was 33. What is it? 33/64. Yeah, 515 thou. Just clearance for a 1/2-inch bolt to go through. All right, we got our 33/64 Chicago Latrobe. Two and a half center to center. There we go. We'll use this little stop over here so we can flip the part over and chamfer in the same position. All right, that's going to finish up the second manifold here. Turned out good, exactly what we needed. Bolt on right there, coolant going in, coolant going out. All right, so here's an overall look at our hardware. We finally got all of our parts and pieces in. This is the one we just finished here. So this is the one that's mounting on the carriage. So we'll have one of these guys right here. We got our hose. This is going to be the hose here. So that'll push on, so that'll be coolant going in. And then this is going to be, we're going to use this 12-inch nipple here. All right, so that'll be coming up out of the lathe, I'm sorry, off of the carriage. And on the top, we've got our ball valve right here. We got an elbow already screwed onto there, so we'll see if we can get this guy screwed in like that. So something like that right there. Coming up. And then, so from here, we're gonna have another short piece of hose with another connector on it in this male quick connect. And then here's our slip ring for our coolant. We're gonna have the quick connect coupling in there. I got a stainless steel bushing in that to reduce it down to the 1/4 MPT. And then that will go into there like so. That's my plan anyway. That should be how it works, something like that. I think we are ready to go ahead and go mount all this stuff on the lathe. Let's see if we can get it all mounted up, see if everything works, and give it a test. So our 2 tapped holes there, I just want to run a tap in there to clean out any kind of rust or crud that might be in there. I'm just going to use a 1/2-13 bottom tap here. And this bottom one right here is a great example of why it's handy to have one of these ratcheting tap wrenches here. This is an old General. And it's reversible, of course. You go the other way with it. But this one's right up here to where the handle is touching this taper attachment. There we go. If you use the tool correctly, it'll help you out. There we go. It does not want to hold a 1/2 inch tap. It's a little beyond its limit there, so we're just making it work. Okay, that's the bottom, so we can reverse it now. Let's see if it'll unscrew by hand. Yep, there we go. Had a little bit of trash in there. All right, there we go. I think I'll bring my angle grinder over here with a Scotch-Brite disc and just kind of polish this a little bit, get rid of some of that paint where my bolt or my block might be hitting that. There's a couple other drilled holes here. I believe those are pins. They might have been tapered pins just to help hold the factory block on here and keep it from trying to shift. But I think our 2 bolts is going to be more than sufficient for that little bitty manifold that we're putting on there. These abrasive wheels here are actually designed for paint stripping and polishing. They work good for stuff like this. I got these from KBC Tools. All right, these are some bolts that I rounded up around here. They'll work. Should fit just like so. A little bit long, but I think we got plenty of depth without having to cut this one off. So we know that one lines up. Let's make sure the bottom lines up. Yep. Oh yeah, looking good. All right, we'll go get our hardware pieces and get those screwed in. I went ahead and got all of our fittings with the Teflon tape to seal up the threads. Went ahead and got all that taken care of. And then I realized going into this, there's one tool that I really don't have in the shop, and that is a good pipe wrench, except for this guy. This is one that I picked up at an antique store some time back. Maybe it'll work. It's made by Greenfield Tap and Die, called the Little Giant 10-inch. Pretty cool little wrench. We'll see if that'll help get these pipe nipples tightened up there. So let's go ahead and start our assembly now. So Wes at Rubber and Gasket, he's the one that helped me with this order, all these parts there. He said the easiest way to handle the hose and these barbs here is to go ahead and get the barb installed and then lube it up with some oil or whatever and then push it on that way. And to get it back off, he said best thing to do is just cut it, split it, and pull it off if you have to remove it. All right, so there's that one. And then we've got our 12-inch pipe nipple here. These are 3/16 stainless. My hopes is that this is going to be rigid enough with this setup here that it doesn't going to feel flimsy when we're trying to handle the ball valve up top. Let's see if I can get our pipe wrench to work. Works just like it's supposed to. I think that's good enough. If we need to, we'll snug them up more if we have any drips or leaks. All right, up top we have our little elbow. Now we'll go on with our ball valve. I want to make sure I have this oriented the right way. Let me come around here. I'd like to be able to pull the valve to me when I'm working it from over here. So yeah, that should be right like that. Yeah, I don't want to go that way. So actually it's going to be, I had it the wrong way. So that's fully open. So that's going to be shut. I guess we can go ahead and rotate that handle if we need to. So we'll just go ahead and, I just don't want this. I think it's going to just clear this. So one of our wrenches fit this. 11/16. Yeah, there we go. Just leave it there for now. So that's wide open. Let's see if we clear the tailstock. Just do. Okay. And I think that's going to be perfectly fine. We have a little bit of wiggle right there, but not a big deal. Once you start using this thing, you're never even going to think about that. All right, take another one of our barbs. So this is the one that when we're not using the drill, I'm most likely going to take this one out, and I'd like to have a different configuration for flood coolant when we're doing standard turning and drilling and things like that. This is going to be the pipe nipple for the pump there. Need to put a coupling on both sides. Doesn't want to catch very well. That should be good enough. Do one this way too. Definitely doesn't want to stay biting into it. We got her working though. Put another one of these barbs on this one. Okay. And then that's going to go right there. I'm just going to hand tighten this one because this is just plastic. I did put some Teflon tape on there. A-bomb torque, that's what we're going to use for that one. All right, we got one more bench work piece to do. That's going to be our slip ring here. Got a pipe reducer. Need to get a wrench for that one. And then this is going to be our quick connect. This one will just stay with the slip ring. Okay. Now we still need to go in there and install our O-rings. We'll do that in a little while. I want to go ahead and see about getting the rest of our piping system plumbed in. All right, here's our other manifold that's going to bolt right here. I'll go ahead and get these started. Nice and rigid there. All right, we're almost done. So I'm going to go ahead and drop our pump back down into the sump here. One thing I may do later, I'm not concerned about it right now, is making some cover plates for this. This one, obviously the pump sat down right there. This side over here actually had just a lid with a knob on it that you would just pick it up for inspection or getting in there. Because the lathe that I used to run had that lid on there. It'd actually be a good thing to maybe grab it and do a copy of it, but we'll fool with that later on. So we have a real short little whip that we're going to make up for right here. I'll go ahead and get that measured and we'll see about getting those on. All right, we've got our little short piece. So this is the hose we're using. It's called InstaGrip. It's supposed to be good for 250 PSI. It should fit right between there. Something like that. And I took a little bit of our soluble oil, our Microsol 685. Just poured a little bit of that. We'll use this for our lubricant since this is what's going through the pipe. Maybe that'll work, hopefully. He said it's pretty tight going on, so let's see. If it's too tight on this pump the way it is, I probably need to pull it out of there. Let's see what we can do. Okay, I think we got her. Now, do we need to shorten that any? Tried to cut it just a touch. I think it's going to be pretty good right there. Let's just go for it. I think that'll be fine. There we go. All right, I think that did it right there. That looks good. Yeah, all right. So I'm going to go ahead and get a measurement on a piece of hose from here, and what we'll do, we're going to come straight across here. I'm probably going to maybe bring this down and go across this way, because this is a good place to just lay tools like live centers and stuff like that you really don't use often. So we'll come over here, and then I'm just going to follow this pipe. We'll zip tie it to that pipe there and go down to that end, and then from there we'll have it kind of loose coming around up to the carriage. I want to make sure that it's long enough that we can, you know, bring the carriage further back here on the machine and be able to go all the way down to the chuck if we want to as well. So get some measurements on that and we'll get this hose hooked in. While I'm sitting here, one thing I wanted to remind you guys of is something I'm concerned about is once we start using the coolant, it's probably going to back up in the chip pan here because this thing's kind of like leaning down a little bit. And the way that this pipe and those sumps are connected to it, there's no way to you know, pick this up where it's more level. So it's going to have to fill this chip pan up some before it starts flowing into those guys in order to get back here. So the pump may end up starving itself for coolant. And what I'm thinking I'm going to do is, I told you before, we got this weep hole right here, and the factory put that in there, I guess, so you didn't overflow the thing with the factory pump. But I bought some pipe plugs, 1/16 and 1/8. And my thoughts is to plug this with a pipe plug. That way we can go ahead and fill up our sump with more coolant for this pump that we're using here. So that's my backup plan in case this doesn't work right out of the gate. I just got the hose and brought it over. We'll go ahead and just route it where we want and then cut it. So we already got that oiled up. Go. We got it routed around. I've been using our zip ties here. I've got it zip tied underneath this pipe. So this is where it'll flex right here. We got it coming up and we'll tie it into our nipple there. And we've got the carriage and the tool post all the way up to the chuck, so this is the furthest that way this should ever go. So we'll just make sure we give that a little bit of slack there. All right, I think that's it. I'm just going to kind of figure out where I want to cut that with a little bit of slack, and then that'll be good, because we also want to make sure, here, let me take this way. We want to make sure that when it's hooked in here, that it'll also come back here. So that's looking pretty good. That's about the midway point. So I think if we're hooked in here and we have a little slack, we should have no worries. I just don't want it sitting down in the chips in the chip pan. I want it to be up off that. I think we're going to cut it right there. So these are my favorite cutters. The Handy Cut, these are old school Craftsman, back when they were made in USA. Perfect for rubber hoses, any kind of hosing, ropes, stuff like that. Does such a good job. Nice, clean cut every time. You guys see these like in an antique store or something like that, I'd advise picking them up. You can still get the blades for these things too. All right, so we need to put a little bit of oil on that one. Let's get our oil. There we go. Just push it up against that little plastic seal there. Plastic bushing, whatever that is. All right. I think that is going to work. We got it up off the chip pan, and that should be plenty of movement if we bring our carriage back here. All right, now we can take what's left of our hose and install it up here on the top side. We'll get our drill mounted in here so that we can make sure that that whip is the right length, and that'll be the last step. I need to go ahead and get our slip ring mounted on here, and just figuring out how this goes. So here's our slip ring. We need to put our O-rings in here, and I'll put some oil on the O-rings before we slide it on there. That'll seal the coolant against this part of the drill here. And then so we got a couple of snap rings, and I'm sure these are going to go between the snap ring and that guy right there. So let's go ahead and get one of these guys on. All right, and then we'll put one of these washers up there like that. And let me get some oil and oil the O-ring. All right, looking good. One more thin washer. And then one more snap ring. I'll get a hammer and a chisel and just tap on that just to make sure that it's seated down in that groove, but should be there. And you can spin this anywhere you need to configure for your hose. And that'll be our flood coolant. All right, let's go get it on the lathe. All right, there's our spade drill. Remember, here's our sleeve that's going to be going into the tool holder here. Not going to lock it in, we're just going to set it in there for now. Probably going to want it something like that, that configuration. Go ahead and tighten it up just a little bit. Okay, and we can rotate that how we want to. I haven't cut the rest of our hose, but I went ahead and put the other nipple on this side. Hook it in just like that. And I'll probably just trim this hose a little bit so that we don't have such a huge piece of hose sticking out, because if I didn't, it's going to be down there in the way. So I'm just going to measure this where I want it and cut it, and I think that's going to be it. This is just going to be used just for this drill. And as I said before, when I want to reconfigure it, we'll take this out and we'll put probably like a flexible nozzle here for general turning. I actually like the look of it going underneath the cross slide right here to kind of get the hose out of the way. So I think I'm going to run in mine like this right here. I kind of like that a little bit better. There it is. We are hooked in. Hooked in. That was all the waste we had. Actually, I'm sorry. There was no, that was it. Besides just trimming the end, that's all. I bought 15 foot of that hose, so we used up just about every bit of that. All right, man, that's looking good. I haven't got the spade drill or the tip installed there yet, but I think we're just about ready for a trial run on this and see what happens. Before we try it, I do want to go ahead and put our drill tip in there. So let's get it installed. So there's a look at our tip once again. If I didn't mention before, these are made out of high-speed steel. These are great because you can go ahead and resharpen them fairly easy. And I do have 2 of them in case I burn one up, I can continue on with the job. And they already have sent me recommended feeds and speeds to run this at, both without coolant and with coolant. They were concerned that I was actually going to be running it without coolant. And I told them that I had planned on getting a system plumbed in, which would be even better. So I think we're going to be good to go. All right, there it is. It's got a really close fit. There's sort of like a pin machined in the center to line it up. And then they do give you a little bit of anti-seize here to use for the screws. And it does have a couple of extra screws to go with it. See if we can get this one on without dropping it down to no man's land. It feels like it ain't starting. There we go. All right, looking good. Put this little anti-seize back in this bag with the extra screws, and we'll put that in the toolbox for all of our lathe tooling. I'm really liking the way this looks. It turned out pretty good. We're about to test it here in a second and see if we have any leaks. I do want to point out the screens for the 2 sumps there are still soaking in the evaporust at the house. They're still getting cleaned up, so we're going to work on those later and get them put back in place here. But here's one more overall shot of our setup. I'm happy with it. I hope it works well. Time to plug it in and see what we got. We're going to start with the pump side first. That way we can check it from here to here, see if we have any leaks. And I decided I'm just going to go ahead and use we've got our cord reel here. I'm just going to pull this over because I got it mounted up there and just plug it in. That way I can kind of keep this cord wrapped up and out of the way whenever we're not using it. All right, so we're ready. That should be shut. Let's go for it. I can hear the pump on. Yep. I'm not seeing any leaks. That's good. All right, here we go. We have coolant. Not quite as much coming out of this orifice here. Must be the pressure of the pump. We may just end up rotating the drill to where both of these orifices are next to each other. Exciting though, exciting to see flood coolant for the first time for me on the pacemaker. I'm just rotating this drill to see if it's going to make a difference on how this coolant comes out. I want to say that this hole is on the bottom, so most of the fluid is naturally wanting to go to that side. Let's see if it makes a difference here. Definitely. I was hoping to see more coolant pressure than that, but this is going to be better than not running flood coolant at all. So, not upset with it at the least. I think we got a good system here that'll get us going. And you know, if we need to upsize the pump because this isn't going to be sufficient, then we can do that as well. But I think this is going to work fine. This is, once it's up in that hole, this right here is going to keep everything nice and cool and lubricated, and I think it's going to do fine just the way it is. It looks like we've got just enough coolant capacity that it is going to work. You can see it's doing exactly what I told you it would do. It would fill up down here in the chip pan. And it's not quite coming up to that plate there, so that's good. But it is overflowing into this sump, and we still have enough coolant there for the pump to siphon. So we are doing good. The only thing that I can critique about this setup is that size pump may be a little bit weak after it's having to push it all the way up here to the drill. But I know that it's going to get the job done. This is going to provide plenty of coolant for our drilling. But if for whatever reason this doesn't work, then I'm going to see about changing that pump out to something with a higher pressure rating. But this is actually working out pretty good for me here. All right, so next phase of this is going to end this part here. Now we got our coolant system working. The last thing we need to do before we can actually test our drill is that I've still got to pin our tool post in place. I'll show you what I'm talking about, but that's probably going to be the next video, getting that pinned and getting our first workpiece in here and drilling it for the first time. All right, I'll show you guys what we're talking about here about pinning this, because that's the issue with using such a large tool with the tool post, is that with the amount of pressure that you're applying on it, it's liable to twist this as it's pushing it in there. So what you have to do, these multi-fix are designed to be pinned in place. So if you take this top plate off, I haven't done this yet, that's why I never did install the spring on here to keep this plate from coming off. And then we take the clamshell off, but you can see, all right, you can see these 3 holes. I don't know if you can see this one, but there's 3 holes. And so what we're going to do is go ahead, and I want to get this nice and indicated on here. And we'll just use a transfer punch and mark our location where our pin needs to be. And then we'll take that off, we'll drill it. This is for a 14 millimeter. I thought it was 12. So I've actually got 14 millimeter pins on order. They should be here today. And once we get it pinned in there, and then this sits back down onto the pin, so that's going to keep it from rotating. The other reason why, the other advantage of having a pin on this is because it actually splits the divisions up. So every notch on this is 9 degrees, and I believe, I haven't looked it up, but I believe by pinning it in one location and then picking the post up and rotating it to another hole location, it actually splits those degrees in half. So I think it's like 4.5 degrees at that point if you rotate it around and dropped it back in. I don't need that kind of, I don't use it for that. I really just, you've seen how I use it, you know, this way, sometimes on an angle. So the only reason I'm going to be using a pin is to keep this thing from trying to twist around as we're using our spade drill there. That's also handy if you're taking really heavy cuts on a shaft or something like that too. All right, so that's going to be the next phase. We'll get it pinned. We'll get this back together. We'll get our first workpiece in the chuck, get it indicated, and we're going to test this spade drill out for the first time. All right.